In this class, we introduce the simplex algorithm in the form of a table, and it is called the tabular form of the simplex algorithm. What we saw in the previous class is called the algebraic form of the simplex algorithm. Essentially, the tabular form and the algebraic form are the same, except that in the algebraic form we write the equations explicitly as we did. We will observe that in the tabular form we represent all these in the form of a table. So, to explain the tabular form, we consider the same example, which after the addition of the slack variables is to maximize 10x1 plus 9x2 plus 0x3 plus 0x4 subject to 3x1 plus 3x2 plus x3 equals 21, 4x1 plus 3x2 plus x4 equals 24. All the 4 variables are greater than or equal to 0. So, we first set up what is called the simplex table. So, let me explain this table. So, first we create a table where we write the variables x1, x2, the problem has 4 variables x1, x2, x3 and x4. So, I write the variables x1, x2, x3 and x4. I also write the objective function value of these variables 10, 9, 0 and 0 above these variables 10, 9, 0 and 0 above the variables. So, I first start with writing x1, x2, x3, x4 and then I write 10, 9, 0 and 0 above the 4 variables. I also write this thing called RHS or right hand side here. Now, my first equation is 3x1 plus 3x2 plus x3 plus 0x4 is equal to 21. So, that is written as 3x1 under x1, 3x2 3 under x2, 1x3 1 under x3, 0x4 0 under x4 and equal to 21, which is written under the right hand side. So, this equation can be read as 3x1 plus 3x2 plus 1x3 plus 0x4 is equal to 21. The second equation is 4x1 plus 3x2 plus 0x3 plus 1x4 is equal to 24. So, this is written as 4x1 plus 3x2 plus 0x3 plus 1x4 equal to 24. So, the two equations are written this way in the form of a table. So, what we have done is we have seen this part of the table. We first started with creating a table like this. You draw this line and then you draw this line and then you say x1, x2, x3, x4 are the 4 variables. Then you draw this line. Then above the 4 variables you write the objective function value 10, 9, 0, 0. Then you write the two equations this way 3x1 plus 3x2 plus 1x3 plus 0x4 is equal to 21, 4x1 plus 3x2 plus 0x3 plus 1x4 equal to 24. Now, just like in the algebraic method, it is easy to begin with x3 and x4 as the basic variables and keep x1 and x2 as the non-basic variables. Now, one can also see that you can see this idea that x3 and x4 are good basic variables, because if you put x1 equal to 0 and x2 equal to 0 in this equation, you will get x3 equal to 21, x4 equal to 24. For example, if we do the same thing, if we treat x1, x4, x1, x2 as the non-basic variables, we are trying to solve 1x3 equal to 21, 1x4 equal to 24. You can now see the identity matrix which is under x3 and x4 and the other one is not there because x1 and x2 are 0. So, the identity matrix straight away gives a solution x3 equal to 21, x4 equal to 24. So, we begin with x3 and x4 as the starting basic variables. So, I am writing x3 and x4 here under a heading which is called xb, which represents the set of basic variables. So, x1, x3 and x4 are the set of basic variables that we are trying to solve. So, what we do is we draw this, extend this line, we draw this line, and then we say x3 and x4 are the basic variables. Now, we extend it a little bit on this side and write something called CB, which is the coefficient of the objective function of the basic variables. So, x3 and x4 have coefficients 0 and 0, and therefore, we write 0 and 0, which are the coefficients of the objective function. Then we write something called Cj minus Zj, and let me explain this Cj minus Zj. Now, j represents the variable, j equal to 1 is the first variable x1, j equal to 2 is the second variable, and so on. So, Cj minus Zj, whatever I am going to write here is C1 minus Z1. Now, Z1 I am going to define as a dot product or product of this and this. So, the product of this and this will become 0 into 3 plus 0 into 4, which is 0. That is your Z1. Z1 because it under the variable x1. So, Z1 is 0 into 3 plus 0 into 4, which is 0. C1 is the objective function coefficient of x1, which is 10. Therefore, C1 minus Z1 will become 10 minus 0, which is 10. Similarly, Z2 will be 0 into 3 plus 0 into 3, which is 0. C2 is 9, therefore, C2 minus Z2 is 9 minus 0, which is 9. Z3 is 0 into 1 plus 0 into 0, which is 0, and C3 is 0 because the objective function coefficient of x3 is 0. Therefore, C3 minus Z3 will become 0 minus 0, which is 0. In a similar manner, C4 is 0, Z4 is 0 into 0 plus 0 into 1, which is 0. Therefore, C4 minus Z4 is 0 minus 0, which is 0. At the moment you find a lot of zeros coming, but as we move along we will see the significance of Cj minus Zj. Or at the moment the Cj minus Zj row seems to repeat this row because all the Zj's are 0. Later we will have situations where Zj's are non-zero and Cj minus Zj will take different values. So, we complete this, we would have drawn this line and then we would evaluate the Cj minus Zj, and then we complete the table by drawing this line. Now, the value of the objective function is 0 into 21 plus 0 into 24, which is 0. So, I multiply 0 into 21 plus 0 into 24, which is 0. So, we complete this table like this. Now, the value of the objective function is 0 and Cj minus Zj values are these 4. Now, find the non-basic variable with the largest Cj minus Zj. The two basic variables are x3 and x4, their Cj minus Zj are 0. The basic variables will always have Cj minus Zj equal to 0. The non-basic variables will have non-zero values. Now, there are two non-basic variables x1 and x2 which are not in the solution, they are at 0. So, their Cj minus Zj are 10 and 9. Find the non-basic variable with the most positive Cj minus Zj. So, if we do that, Now this is the variable x1 which has the highest Cj minus Zj. So variable x1 comes into the solution. Now when this comes into the solution, it has to replace x3 and x4 because only two variables can be in the solution. There are two equations, so only two variables can be in the solution. Now which one does it replace? To find out which one it replaces, we calculate this thing called theta. So just draw this line and write theta here, and then this theta is the ratio between this 21 and this 3 corresponds to the variable that is entering. So 21 divided by 3 is your first one. So 21 divided by 3 is 7 and 24 divided by 4 which is 6, and take the smaller theta which is 6. You also have to make sure that when you do this division, the denominator is not 0 or negative. You will realize that the numerator will be either 0 or positive, and most times it will be positive. The numerator, the right hand side value will not be negative, but the denominator which is obtained from here can be 0 or negative. When we have a 0 or negative as a denominator, we do not evaluate that value. Now at the moment both numerator and denominator are positive, so we got 6, and 6 is the limiting value and which is shown here. So the variable x4 will go out of the solution and the variable x1 will come into the solution. So this is one iteration of the simplex table. Now we proceed now, and I have written the same iteration here already, and I have drawn the next table using these black lines. So now we know that this is the variable that is coming into the solution, x1 is the variable that is coming into the solution, x4 is the variable that is leaving the solution, x1 is the variable that is coming into the solution. So what I do next is, I write x3 and x1 as the basic variables. x1 is coming into the solution and it is replacing x4, so I am writing x3 and x1 has replaced x4 in this solution. Now as soon as I write x3 and x1, the next thing I have to do is to write the objective function coefficients of x3 and x1, so I write 0 and 10. 10 is the objective function coefficient for x1. Now what I do is, this element which is 4, which I have shown in a different color, is the intersection element between the entering variable x1 and the leaving variable x4, and this 4 is called a pivot element. It is called pivot element. It is called the pivot element, and this x4 row is called the pivot row. It is called the pivot element, and this is called the pivot row. So now take the pivot row and divide every element of the pivot row by the pivot element. So 4 by 4 is 1, 3 divided by 4 is 3 by 4, 0 divided by 4 is 0, 1 divided by 4 is 1 by 4, and 24 divided by 4 is 6. You will also observe that you have already written this 6 here, and the same 6 will come because this 6 is also 24 divided by 4. So we have now rewritten the pivot row in terms of x1. Now we have to rewrite it in terms of x3. Now to do that, we do some row operations as we do in the Gauss-Jordan method of solving equations or inverting a matrix. Now what are these row operations? Now we realize that if x3 and x1 represents our solution, then just in the earlier one you realize that x3 and x4 was representing the solution, and we saw the identity matrix with x3 and x4. Now here x3 and x1 represent our solution, so we should have an identity matrix under this x3, we should have an identity matrix under this x3 and under this x1. So I should have a 1 here and I should have a 0 here, so that I get the identity matrix under. So in order to get a 0 in this position, now I look at the previous one, which is 3, here there is 1, so 3 minus 3 times 1 will give me 0. So what I do is I put 0, which is 3 minus 3 times 1 is 0. Now I repeat, 3 minus 3 times 4, 3 minus 3 times 3 by 4. So 3 minus 3 times 3 by 4 is 3 minus 9 by 4, 12 by 4 minus 9 by 4, which is 3 by 4. Now here it is 1 minus 3 times 0, so I will get 1. Here it is 0 minus 3 times 1 by 4, which is minus 3 by 4, I get minus 3 by 4. 21 minus 3 times 6, 21 minus 18, which is 3. So once again, to get this row I need a 0 here, so I look at the previous element, 3 minus 3 times 1 is 0, 3 minus 3 times 1 is 0. So 3 minus 3 times 3 by 4, 3 minus 9 by 4 is 3 by 4, 1 minus 3 times 0 is 1, 0 minus 3 times 1 by 4 is minus 3 by 4, 21 minus 3 times 6, 18 is 3. So we now have a solution, x3 equal to 3, x1 equal to 6. Now we write the Cj minus Zj. So we write Cj minus Zj. Now Z1 is 0 into 0 plus 10 into 1, 10. So 10 minus 10 is 0. Z2 is 0 into 3 by 4 plus 10 into 3 by 4 is 30 by 4. So 9 minus 30 by 4 is 36 by 4 minus 30 by 4, which is 6 by 4, which simplifies to 3 by 2. C3 minus Z3, Z3 is 0 into 1 plus 10 into 0, 0. So 0 minus 0 is 0. Z4 is 0 into minus 3 by 4 plus 10 into 1 by 4, which is 10 by 4 or 5 by 2. So 0 minus 5 by 2 is minus 5 by 2. And the value of the objective function is 0 into 3 plus 10 into 6, which is 60. So we have now completed the second iteration of the simplex algorithm, where we now have a solution with x1 equal to 6, x3 equal to 3, with Cj minus Zj equal to 6, with the objective function value equal to 60. Now we wish to increase the objective function further, and we realize that the basic variables have 0 Cj minus Zj. The non-basic variable only x2 has a positive value. So enter the most positive non-basic variable with the most positive Cj minus Zj. Now we have to find out that x2 has to replace x3 or x1. To find out which one it replaces, 3 divided by 3 by 4, which is 4, 6 divided by 4 by 3, which is 8, or 6 divided by 3 by 4, which is 8, 6 into 4 by 3 is 8. The limiting value is 4. Therefore, the variable x2 will now replace the variable x3. And then we move on to the third iteration, which is shown here, and in the third iteration the variable x2 has replaced the variable x3. So we now write this, x2 has replaced x3, so the basic variables are x2 and x1. Now when the basic variables are x2 and x1, the value of the objective function coefficients are 9 and 10 respectively. Now this is the pivot row, now this is your pivot element and this is my pivot row. So like we did last time, divide everything by the pivot element. So we get 0 divided by 3 by 4 is 0, 3 by 4 divided by 3 by 4 is 1, 1 divided by 3 by 4 is 4 by 3, minus 3 by 4 divided by 3 by 4 is minus 1, 3 divided by 3 by 4 is 4. Now I have a 1 here, since I have x2 this should be 1 0 and this should be 0 1, I require a 0 in this position. Now I require a 0 in this position. Now to get a 0 in this position, only then I will have the identity matrix corresponding to x2 and x1. So 1 0 0 1, I need a 0 in this position. So I go back to the previous value which is 3 by 4. So 3 by 4 minus 3 by 4 into 1 is 0. So 1 minus 3 by 4 into 0 will become 1. So I repeat this and I get, so 1 minus 3 by 4 into 0 is 1, 3 by 4 minus 3 by 4 into 1 is 0, 0 minus 3 by 4 into 4 by 3 is minus 1, and 1 by 4 minus 3 by 4 into minus 1 is 1 by 4 plus 3 by 4 which is plus 1. 6 minus 3 by 4 into 4 is 6 minus 3 which is 3. So we now have a solution x2 equal to 4, x1 equal to 3. Now we compute Cj minus Zj. So for the first one, 9 into 0 plus 10 into 1 is 10, so 10 minus 10 is 0. For the second one, 9 into 1 plus 10 into 0 is 9, 9 minus 9 0. For the third one, 9 into 4 by 3, 36 by 3 which is 12, 12 minus 10 is 2, so 0 minus 2 is minus 2, and for the last one 9 into minus 1 is minus 9, plus 10 into 1 10 is plus 1, 0 minus 1 is minus 1, and the value of the objective function is 9 into 4 36 plus 10 into 3 30 which is 66. Now we see whether we can enter another variable. The basic variables have 0 value x1 and x2, the non-basic variables have negative value. We are not able to enter a variable, the algorithm terminates giving this solution x1 equal to 3, x2 equal to 4 with objective function equal to 66. So we have now completed the problem in the form of the simplex table which gives us the same solution. Other aspects of the simplex table we will see in subsequent classes.